Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on February 8th, 2026, exactly 1 week ago. It introduces a training-free method called rolling sync that allows models trained on just 5-second clips to generate consistent videos lasting anywhere from 5 to 30 minutes. The paper is titled Rolling Sync, Bridging Limited Horizon Training and Open-Ended Testing in Autoregressive Video Diffusion. And as we'll see later, the ability to maintain subject identity over such long durations is really impressive. Well, Figure 1 immediately demonstrates this capability with 2 visual examples. The top sequence tracks a snowboarder navigating a slope, while the bottom sequence follows a surfer on a wave. The crucial detail here lies in the timestamps, which extend from 1 second all the way to 300 seconds. Despite the model seeing only 5-second clips during training, it preserves the subject's identity and the scene's structure for a full 5 minutes. So, while Figure 1 showed the ideal outcome, Figure 2 reveals the degradation that typically plagues these models. On the left, rolling sync keeps a horse riding scene crisp and stable for a full minute. Contrast that with the middle column, which uses the standard self-forcing baseline. It looks fine up to the 5-second training mark, but immediately after, it collapses into severe visual noise. The diagram on the right illustrates this autoregressive drift, showing how the baseline diverges from the valid video manifold, while rolling sync actively corrects the path to stay on track. Alright, Figure 2 showed the failure, and now Figure 3 details the fix. Panel A shows the baseline self-forcing, where early blocks like X0 are evicted, causing identity loss. Panel B tries to fix this with an attention sync, pinning initial blocks to anchor the style. Panel C adds sliding indices, updating their timestamps to keep them relevant. Finally, Panel D unveils the full rolling sync. It actively rolls recent history into the sync, preserving both the subject identity and the ongoing motion dynamics. So, having seen the mechanism in Figure 3, Figure 4 quantifies the resulting boost in video quality. These charts track performance on 1-minute and 5-minute videos, plotting the versus bench long quality score against the sync size ratio. The blue line shows the basic attention sync, which lags behind. The orange line adds sliding indices for a solid improvement, but the green line, representing the full rolling sync, consistently stays on top. Notably, the best results appear when the sync occupies about 83% of the cache, confirming that a larger sync generally leads to better stability. Well, while Figure 4 gave us the numbers, Figure 7 provides the visual proof. It compares rolling sync against baselines like self-forcing and long-live in 2 scenarios, a boxing match and a wedding dance. In the top boxing example, the baseline methods in the first 2 rows rapidly degrade, producing oversaturated colors and collapsed structures by the 30-second mark. In contrast, the rows for rolling sync show the model maintaining consistent identities and smooth motion all the way to 300 seconds. This stability repeats in the wedding scene below, where the couple's faces remain clear long after the baselines have failed. So, while the previous figure offered visual proof, Table 1 confirms those observations with hard metrics. Here, the authors benchmark rolling sync against these self-forcing and long-lived baselines on the 1-minute vbench long suite. The results are striking. Rolling sync achieves the highest score in almost every category, notably dominating in subject consistency and spatial relationships. This consistent performance is summarized in the final row, where the method attains the best average rank of 1.38, clearly outpacing the competing approaches. Alright, while the previous table focused on 1-minute clips, Table 2 pushes the test horizon out to 5 minutes. Here, the performance gap becomes even more pronounced. Rolling sync achieves the top score in nearly every category, notably hitting perfect scores in object class and spatial relationships. The final row drives this home, showing an average rank of 1.25, significantly better than the baselines, which struggle to maintain coherence over these ultra-long durations. Wrapping up, 2 takeaways stand out. Rolling sync proves that expensive long video training isn't the only path to extended coherence. By smartly managing the attention cache during inference, the method effectively bridges the gap between short training clips and open-ended testing. This offers a highly efficient blueprint for future video generation models. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.